PPTC 121. Power Plant Steam Systems Session 9. Purpose of the session. The purpose of this session is to explain the basics of good combustion in the modern fossil-fueled power plant. Agenda. Understand the 3 T's of combustion. Understand the fundamentals of combustion. Understand the control of air. Understand the mixing of air and fuel, turbulence. Understand the temperature required for combustion. Understand that it takes time for complete combustion to occur. Define a clinker and slag. Define combustion. Understand change of state. Understand the gas laws. Understand how to measure temperature in deg of Rankine or Kelvin. Agenda. Understand the physical and chemical properties of different substances involved in combustion. Define the stoichiometric ratio. Understand how the combustion process makes sulfur dioxide and nitrogen oxide. Understand complete and incomplete combustion. Define excess air. Understand how O2 can be used. Measure excess air. Define draft and understand how to measure it. Understand the function of an FD fan and an ID fan. Define a windbox. Combustion. Combustion or burning is the sequence of exothermic chemical reactions between a fuel and an oxidant accompanied by the production of heat and conversion of chemical species. The release of heat can result in the production of light in the form of either glowing or a flame. We all know that in order to have a fire it takes oxygen, fuel and heat. However, to have a good fire you need the 3 T's of combustion. They are time for combustion to take place, temperature for combustion to initiate, and turbulence to allow the fuel and air to find each other. The fundamentals of combustion include the control of air, the mixing of air and fuel, turbulence, and the temperature required for combustion. That it takes time for complete combustion to occur. The air has to be controlled with the proper amount of fuel. The higher the oxygen, the more fuel can be burned. If you fall below the proper fuel to air ratio, the more CO increases. If you fall below the proper fuel to air ratio, the more unburned fuel you have. The highest efficiency occurs at a point where there is a small amount of O2 remaining. If you have too much air, you lose efficiency in the combustion process. So the air must be maintained with about 3% oxygen remaining in the flue gas after combustion. Another important factor in maintaining a good fire is the mixing of the fuel and air. This is done with the modern burner by creating swirls in the fuel and air as each leaves the burner, and thus creating turbulence. Higher the temperature, the better the combustion. When the combustible material reaches its ignition temperature, oxidation is accelerated and the process is called combustion. It is important to maintain the fuel and air mixture at a temperature high enough to promote combustion. Also, if the fuel contains moisture, The moisture must be driven off before a fire can take place. The combustion air temperature in the modern boiler is increased to over 500 degrees by the air heater, which uses the temperature remaining in the flue gas after it leaves the boiler to increase the combustion air temperature. It takes time for complete combustion to occur. Air supply, mixing, and temperature determine the rate at which the combustion progresses. In all cases, an appreciable amount of time is required to complete the process. The result of insufficient time is a large quantity of unburned fuel, and high temperatures in the upper sections of the boiler. These high temperatures lead to slagging in the superheater sections, higher than normal steam temperatures, and a loss of efficiency. A clinker is lumpy form of unburned coal residue that form hard lumps of ash and partially fused coal after burning. Slag is a term for liquid bottom ash. Change of state during combustion. Fuel matter is encountered in either a solid, liquid, or gas. Solids have a definite volume and shape. Liquids has a definite volume. Gases has neither. The situation is that solid fuel needs to be converted to gas before it can be burned. The gas laws affect the temperature, volume, and pressure. It is important to understand this since the combustion drastically increases the temperature and as thus the volume also increases. This increase in volume has to increase the velocity of the hot gases flowing through the furnace, and can decrease the time needed for proper combustion. The gas laws are, at constant temperature, V1 V2 equals P2 P1. At constant volume, P1 P2 equals T1 T2. And at constant pressure, V1 V2 equals T1 T2. Temperature and pressure must be in absolute values. How do we measure temperature in degrees of Rankine or Kelvin? Rankine temperature is Fahrenheit temperature plus 460 degrees. Kelvin temperature is Celsius temperature plus 273 degrees. These two scales measure absolute temperature and are used in evaluating the gas laws. Physical and chemical properties of different substances involved in combustion. Some of the important things that you review are the differences in specific volume and heating values for the different components involved the combustion of coal. Stoichiometric ratio. The theoretical proportions, no deficiency and no excess of elements or compounds in a chemical reaction is referred to as the stoichiometric ratio. For a given element requires a definite amount of oxygen to complete combustion. The law of combining weight states that the elements and compounds combine in definite proportions that are in simple ratio to their atomic or molecular weights. The combustion process makes sulfur dioxide and NOx in the combustion process. 1 pound of sulfur combines with 1 pound of oxygen to form 2 pounds of sulfur dioxide. Sulfur dioxide divided by pounds per million BTU equals sulfur dioxide pounds per hour times 1 million divided by fuel in pounds per hour times BTU per pounds of the fuel. The EPA has definite limits on sulfur dioxide emissions from a power plant. The nitrogen combines in small amounts with oxygen to form nitrogen oxides, commonly called NOx. Complete and incomplete combustion. Complete combustion denotes the complete burning of the fuel by supplying more than theoretical amount of air. Incomplete combustion occurs when a portion of fuel remains unburned because of insufficient air, improper mixing, or other reasons. Excess air. Excess air is the air supplied to a combustion process in an amount above the theoretically required amount. O2 can be used to measure excess air. The percentage of oxygen in the flue gases provides an adequate measurement of excess air when either single or multiple fuels are being used. Percentage of excess air equals O2 0.263 and 2-O2 times 100%. This formula is true only if there is no CO produced. An ORSAT analyzer can be used to take these measurements. See Analysis B in your book, page 181. Draft and how to measure it. The circulation of gases is caused by a difference in pressure, referred to in boiler practice as draft. Draft is the differential in pressure between 2 points of measurement, usually the atmosphere and the inside of the boiler setting. A pressure in the furnace slightly lower than atmospheric causes air to enter, and thus oxygen for combustion. A draft at the boiler outlet greater than that in the furnace causes the products of combustion to circulate through the unit. What are the functions of the FD fan and the ID fan? The forced draft fan, FD, provides combustion air to the boiler. The induced draft fan, ID, provides the draft necessary to remove the products of combustion from the furnace. The ID and FD fans are two large fans on a boiler. The ID fan pulls the draft on the boiler, and the FD fan establishes the windbox pressure to the burner. Both fans are normally centrifugal fans, but newer design of ID fans have gone to axial flow fans, because they are quicker responding with a higher capacity. Forced draft fans, FD fans, take a suction from ambient air. Forced draft, often called secondary air, is ducted through an air preheater, which prewarms the air prior to entering the boiler. FD/secondary air enters the boiler windbox and is added to the coal/primary air mixture. No longer fuel-rich, the coal-air mixture ignites at the burner tip. Induced draft, ID, fans. While forced draft fans supply secondary air to the windbox for combustion, induced draft fans pull air from the boiler furnace. Induced draft fans provide a negative air pressure in the boiler furnace. A negative furnace pressure aids the air flow through the boiler and keeps fine particles and flue gas out of the power plant building. Balanced draft versus pressurized furnace. Operating a furnace at a constant draft slightly below atmospheric pressure is referred to as balanced draft. Pressurizing the furnace above atmospheric pressure is called a pressurized unit. Pressurized coal units aren't very prevalent, since any gas leak sends products of combustion into the neighboring atmosphere. They don't require an induced draft fan. The windbox is an enclosure that provides the air distribution to the burner dampers for proper combustion. The windbox is a reinforced, metal-cased enclosure that attaches to the furnace wall and incorporates the burners, and distributes the combustion air. The air coming from the air heater pressurizes the windbox. That pressure is normally above 35 inches of water column,